Hello everyone, welcome all of you. This is me Aditya Arya, Master of Mathematics, and guys, we are going to solve a question from Singapore Mathematical Olympiad. So, if you are a keen lover of mathematical problems, and if your target is to, or if your target is to go for any of the Olympiad, or specifically the Singapore Mathematical Olympiad, this video is for you. Alright, guys, let's start. And you can take your 2 or 3 or 5 minutes. You can pause this video right now. And once you're done with your thoughts, with your attempt, you can start watching this video. Alright, so I'm jumping to the solution portion how we are going to solve this question. Find all integers sided triangles. This is very important. Now let's say the sides of triangle are A, B, and C. Alright, guys. Now whose area equals to parameter. Now area is equals to parameter. Those who I would say those who are going for this question should know what is the area of triangles, and we are having many formulas, but the main formula, or you can say, well, is 1 by half, sorry, 1 by 2 half base into height, but definitely we are not going to use it. We are going to use the one which is having some relation with parameter. So what is the area? It's a Heron's formula, root of s into s minus a into s minus b into s minus c. What is s? S means semi-parameter. Alright, guys. And parameter will be equals to, if s is semi-parameter, then p will be equals to 2s will be equals to parameter. Alright. Now take square both the sides. If you will take square both the sides, you will be having s into s minus a into s minus b into s minus c is equals to 4s square. We will cancel s with s, and what you will be having is minus a into, guys, this is really a very good problem which I have solved among many of the Olympiads. So I would say, like, yeah. So I have solved problems from American Olympiads also, British Olympiad also. I have also solved a problem from Dutch Olympiads. But I found these ones, this even the Indian Olympiad. But I found the Chinese Olympiad is a very good one. Singapore Olympiad is a very good one. International Maths Olympiad definitely very good. So these exams can help you. All right. So coming back to this question, so SS cancel, this will be equals to 4s. Now, what I'm going to do is write down S is equals to A plus B plus C by 2. So I'm directly putting the value and writing the outcome part. All right. So you can pause this video right away and you can first get your calculation done. So after solving this, since I can do it directly, B plus C minus A, and here you will be having A plus C minus B, and here you will be having this as A plus C minus B is equals to, now you will be having 4s, so I can write down this will be equals to 2 into A plus B plus C. So converting everything in terms of ABC. Now what I'm thinking, if I can assume this as x, small x, this is small y, this is small z. Okay, so this part will become as x, y, and z. Yeah, my mistake. 1 by 2, 1 by 2, 1 by 2. This becomes 16 by. So over here, replace this as 16. All right, this is the only change that we need to have. So we will have x, y, z is equals to 16 times of x plus y plus z. Okay, you can just put the values over here. What values? X is equals to b plus c minus a, y equals to a plus c minus b, z equals to a plus c minus b. You will get to know a plus b plus c is x plus y plus z. This is what one conclusion that you are going to have. Apart from that, we are going to have one more conclusion, that if I will add, let's say, if I will add these two, okay, if I will add these two, I am going to have the value of a as y plus z by 2. Okay, I'm going to have b as, if I will add this one and this one, first one, last one. If I will z, x and z, so I'm going to have b is equals to x plus z by 2, and similar way I'm going to have c is equals to x plus y by 2. Okay. Again, so whenever you feel like this some calculation I have done it directly, you can take a pause and you can start solving. You can Take your time to solve it. I am not investing my time in this video to solve the calculation part, which I haven't already. So coming back to the point now here, what is the conclusion point? A is an integer. If A is an integer, it can only happen if y plus z is an even number, because odd by 2 cannot be integer. So y plus z is even. Now if y plus z is even, it can only happen if y and z both are odd or both are even. Similar conclusion we can have over here. X and z both are odd, both are even. So we can have one conclusion: x, y, and z all are odd, and x, y, z all are even. All right, that's what we can have. Now, if you look over here, if x, y, and z all are odd, then multiplication of x, y, z becomes odd. But on the right hand side, 16 multiplied something is going to be even. So that's not a clear cut case. The only thing that we will have is x, y, and z all are even. All right. Now, coming back to the point back again, if this is so, I'm writing small x as 2 times of capital X, small y is 2 times of capital Y, and small z is 2 times of capital Z. Okay, what is how it is going to help me? First thing is, since I have declared x, y, and z, I have concluded x, y, and z, small x, y, z are even. So writing this is 2 times, because every even number is multiple of 2. What is the benefit of it? If I will put the capitals X, Y, and Z over here, I am going to have small a as capital Y plus capital Z. Small b as capital X plus capital Z. Okay. Small c as capital X plus capital Y. All right. So this is now much simplified version. And if I will put values of this small x, small y, small z over here, what I'm going to have, guys, is capital X into capital Y, capital Z is equals to 4 times of capital X plus capital Y plus capital Z. This is first phase of question, which was very easy, I would say. But after that, it really blows my mind. I have to put some efforts to go further on this. So after putting some time, getting some conclusions, so here is the best solution which I can give it to you. So listen very carefully. So here I have to make some assumption, because x is less than equals to y is less than equal to z. So z is the greatest side. Okay. So I want to find out the maximum value of x, y, z. So I can write down x, y, z, which is equals to 4 times of x plus y plus z. So I'm checking this should be less than equal to, means what can be the maximum value? X plus y plus z can be maximized if x and y both becomes equals to z, reaching to the highest point. This is very important point. Think again. X plus y plus z. So it's like it's like key x, y, and z can be maximum when x is also z, reaching to the highest value of it, y reaching to the highest value of it, which is z, because here I have assumed z is the highest one among them. So I can write down this as equals to z plus z plus z. So here I can write down x, y, and z is equals to, sorry, not equals to, less than equals to 4 into 3z, which is 12z. Z can cancel out, because we can cancel since z cannot be 0. I will have x, y less than equals to 12. This is very important conclusion. Now you can start with, like, if x is equals to 1, then y needs to be less than equals to 12. If x is equals to 2, then y needs to be less than equals to 6. If x is equals to 3, then y needs to be less than equals to 4. If x is equals to 4, then y should be less than equals to 3, which is not possible, because we have already assumed that x is less than equals to y, and after that you are going to have circular. So once we are done with this portion till now, we have concluded that x equals to 4 is not possible, or after that it's not possible, because your y or z will become lesser than what we are expecting. All right, guys. So let's analyze this first situation first. And if x is equals to 1, and if I will put the values over here in this equation, x, y, z equals to 4 times of x plus y plus z, what we are going to have, if I will put x equals to 1, so what we will have, that x is equals to 1 into y z is equals to 4 times of x plus y plus z over here. In this case, what also we have concluded, if x is equals to 1, you can see over here that y should be less than equal to 12. And how we have got it? By doing this analysis. Very important analysis, which is, you can see, the turning point of this whole question. So we have to make sure that our y needs to be less than equal to 12. All right, guys. So let's solve this one. You will have y z is equals to 4 plus 4 times of y plus z, or I can write down like 4y plus 4z. And if I will bring all the terms on the other hand, I will be having this as 4y. Okay, sorry, capital Y. Okay, make sure that you will not do any mistake. 4y plus 4 capital Z minus yz, and we are having plus 4 over here equals to 0 as we are having. So if we will take y common from here, so what we are going to have, take y common, and I will be having 4 minus of capital Z. But now I'm hoping that I can take 4 minus z common from here and here, but as of now I cannot do so. So if just imagine if I'm having 4 minus z over here, I can manage the constant part, I cannot manage the variable part. All right. So I should have minus 4 over here. And this gives us an hope. Minus 4 into 4. Minus 4 into 4z. So the only thing that we are adding is minus 16 both the sides. That's what we are doing. Okay, so 4z and minus 16, from here we are taking minus z common. And from here, if I will send 4 on the other side, we will be having minus 4 minus 16. Hope this is clear to you. So now if we'll take 4 minus z common, and then we'll be having y capital Y minus 4, v is equals to minus 4 minus 16 is equals to minus 20. If you want, you can cross multiply with minus 1 both, sorry, multiply with minus 1 both the sides, you'll be having y minus 4 into z minus 4. That's how we will do it. So I have done this calculation part because it was a bit tricky, you can say. Now y minus 4 into z minus 4 is 20. Now you can think of a number like, since y and z, capital Y and Z are also integers. It's mentioned at the beginning. If we can just show you that sides are integer, if sides are integer, small x, y, z are even numbers, and if small x, y, z are even number, capital X, Y, Z are integers. That's what we can conclude from here till now. Okay, so like it can be 1 into 20, it can be 2 into 10, which is 20, it can not be 3, it can be 4 into 5. If you'll go further, it's not possible. Let's, you can just try 5 into 4, or you can try for like 10 into 2. That's all, I guess. Yeah, because 20 is, if I'll just think of writing 2 square into 5 power 1, so 3 into 2, 6. 1, 2, 3, 4, 5. 1 is 20 into 1. So you have to make sure that x is less than equals to y in this case, all right? This is what we have to make sure. So if y minus 4 is 1, we will have y is equals to 5. So we are getting one pair, x is equals to 1, y is equals to 5, x is equals to 1, y is equals to 5, and z is equals to 24. Okay, so this pair is justified. If y minus 4 is equals to 2, then capital Y is equals to 6, and capital Z is equals to, capital Z is equals to 14 when x is equals to 2. Okay, I hope it is clear. Sorry, x is equals to 1, my mistake. Because we are solving all this for the case x equals to 1. If x is equals to 1, then y minus 4 is equals to 4 means y is equals to 8, and z minus 4 is equals to 5 means z is equals to 9. Till here it justifies that x is less than equals to y less than equals to z. But all these cases will not fulfill the case, because here z will become 9 and sorry, y will become 9 and z will become 8. So hence in these conditions, not possible, I would say. All right. Now from here, before I further move, I have got at least 3 solutions. The question was the number of solutions we can have, number of trios of the sides. So these are capital X, capital Y, capital Z. If I will show you one more time, small a, the side is a summation of two of them, two of the capital X, Y, and Z. So from here I can say, now sides A, B, C can be, now this is final conclusion. 1 plus 5, 6. 1 plus 24 is 25. And 5 plus 24 is 29. And we have to make sure that sum of two sides should be greater than the third side, which satisfied over. You can cross check. This one is done. Now 1 plus 6 is 7. 1 plus 14 is 15 and 6 plus 14 is 20. Now sum of any two sides is more than third side. That's for very sure in this question also. So this is also justified. 189, let's take. So 1 plus 8 is 9 and 1 plus 9 is 10 and 9 plus 8 is 17. Sum of any two sides is more than third side. So it's justified over here also. So that means we have got till now three solutions. Let's work on the other solutions, guys. So over here, if x is equals to 2, all right. If x is equal to 2, we have to make sure that y is less than equals to. So let's check over here. Y needs to be less than equal to 6. Okay. Now, if x is equal to 2, so 2 into y into z is equals to 4 times of x plus y plus z. Here x is kept as fixed as 2. So 2 and 4 got cancelled. You will have y z is equals to 2 into 2 is 4 because 2 and 4 will cancel out as 2. 2 into 2 is 4 plus 2 times of y plus z. We will have exactly same technique. And after going through this, what we are going to have, if I will write down everything on one side, so 2y plus 2z minus yz plus 4 is equals to 0. If I will take from here and from here, if I will take y common, I will be having 2 minus of z. Okay. Again, same thing. I am expecting to have 2 minus z common from the next one. But I cannot manage this part, but I can manage this part. The constant part I can manage, but your part I cannot manage. Okay, so I need to produce 2z, so I will multiply minus 2. So minus 2 into minus z is 2z. Minus 2 into minus 2 is minus 4. So I need to add and subtract minus 4 both the sides. So minus 4 and minus 4. Alright, guys. So we can see that these two terms got converted to this. These two terms get converted to this one. 4 will go on the other side and we will be having this equals to minus 8. Solve this one, you will be having y minus 2. 2 minus of z, which I can write down minus times of z minus 2. Minus and minus 8 becomes 8. Alright, so y minus 2 into z minus 2 is 8. Now think of the numbers. Alright, think of some numbers like if x is equal to 2 that we are having already. Now, if what we can have as multiplication 8, like 1 into 8, we can have 2 into 4, we cannot have 3, we can have 4, but see, it is not going to work because here in these two cases, you will see y is more than z, which is against our assumption. Alright, so if y minus 2 is 1, then we will have y is equal to 3, at x equal to 2, y is equal to 3, and z equal to 10. We have got one more pair of x capital Y capital Z. And if y minus 2 is equal to 2, then at x equal to 2, we are having y equals to 4 and z is equal to 6. Alright. So if this can be the solution, so as we have said, sides A, B, C are addition of any two of them. So 2 plus 3 is 5, 2 plus 10 is 2 plus 10 is 12, and 10 plus 3 is 13. You can check sum of two sides is more than third side, and in special case I guess this is a right angle triangle. Over here, 2 plus 4 is 6, 2 plus 6 is 8, and 4 plus 6, again this is the right angle triangle. This is again very important. So next they can ask you, okay, how many right angle trios we are going to have from this solution. So total we are having 5 till now, 5 solutions where sides are in integer format, and apart from that we are having area is equal to perimeter. That was a main condition on the basis of which they have asked the question. Now our final situation, final condition, we have done with this. From here we are having 3 solutions, from here we are having 2 solutions. This has been cancelled out, it's not possible. X equal to 3, okay, fine. If x is equals to 3, okay, if x is equals to 3, and in that case y needs to be less than equal to 4. All right, now understand, y needs to be less than equals to 4. There are two possibilities in this case. Either y can be equal to 3 or y can be equals to 4. There is no other case, right? I can directly solve without going through the all. So x, y, z, x into, if I am taking y equal to 3, okay, x into y into z is equal to 4 times of x plus y, so 3 plus 3 is 6 plus z. You will solve it. 3 into 3 is 9z is equal to 4 into 6 is 24 plus 4z. From here you will have 5z is equal to 24 and you will have no integer solution. Hence this is a not possible case. If you will take z is equals to, if you will take y is equals to 4, so x is equal to 3, y is equals to 4, so 3 into 4 is 12, z. And 4 times of x plus y plus z, x is 3, y is 4, so 3 plus 4 is 7 plus z. And 12 times of capital 4 is equal to 28 plus 4z. From here you will have 8 capital Z is equals to 28. Again, we are not going to have any integer. Hence, till now we are having 5 solution and that's the final conclusion. So, question was find all integers triangles, and if the question is number of such trio of the sides we are or number of such triangles which satisfy these conditions having integer sides and area is equal to parameter, it will be 5, and we are having what the sides should be. Okay, so the three are here, three are from here, and two are from here. I hope guys this whole video is very clear for you, and do not forget to may write down the comment like, is everything very clear to you? Have I helped you, or was this question interesting? Or if you want me to add such more question, and you can show me your love for mathematics. Till then, take care. Bye bye. See you all in the next question with a new video with another Olympiad problem. Bye bye. Take care.